So today we're going to be solving rational and radical equations. In algebra, rational is the same thing as fraction. Use them interchangeably. Radical refers to the square roots, cube roots, fourth roots. We've already worked with square roots. That was our very first assignment. And so if you want to get full credit for the assignment, you got to click on these over here and get the green check. Now, a little bit about fractions. A number divided by 0 is undefined. If you punch that into your calculator, it's going to give you some sort of error message. A number divided by 0 is undefined. Right? And you can convince yourself by looking at a calculator. You go any number divided by 0. Ooh, let me see all of that. Let's say 5 divided by 0. Sometimes people don't believe it until they see it on a calculator. Undefined. This is one of two error messages that you'll get on your calculator this semester. Division by 0. There's another error message that you'll get. And that is with imaginary numbers. We know that the square root of negative 25 is the imaginary number 5i, but this calculator works only with real numbers. And so it says error, non-real answers. So there's the two types of errors that you'll get. But fractions are undefined when the 0 is in the bottom. If the 0's on top, like $0 divided by 5 people, that's easy. Everyone gets $0. Okay? So if the 0's on top, then the answer is 0. If the 0's on the bottom, that's when you get undefined or some sort of error. Let me write down a rational expression. When is this fraction 2x plus 5 divided by x minus 6 undefined? And by when is, I mean at what value of x? What value of x would make, let me get rid of that calculator. What value of x would make this fraction undefined? A positive 6, yes. This bottom here cannot be 0. And therefore, solving this for x, x can't be positive 6. Okay. Now, the first two problems of this assignment, I sort of wish the instructions had been worded just find where this fraction is undefined. Okay. What values of the variable cannot possibly be solutions? Well, we're going to be solving these equations like this in a moment, but right now we're not actually solving it. All we're trying to do is figure out the two numbers that aren't solutions. In other words, when is it undefined? It would have been nicer if it had just asked, when are these fractions undefined? So let me write this one down. This is problem number 1 on homework 5. We're just moving on along. 8 over 4x plus 5 minus 1 over x minus 4 equals 0. Well, I'm going to pick on the second fraction just because I think that's the one that's easier to figure out. You can almost do it in your head. This second fraction right here, the 1 over x minus 4, what value of x would make this 0 down here? 4. X minus 4, so here I'm just showing my thoughts. So x can't be, oh shoot. Yeah, you're right. Slip by. X minus 4 can't be 0, so x can't be 4. But doing the same thing with the 4x plus 5, that one's a little bit more involved. then we're going to wind up with a fraction. That denominator, that's a not equal to. 4x plus 5 cannot equal 0. Isolate x. I'd move the 5 over. So 4x can't be negative 5. And then what would I do to get the x by itself? Divide by 4. So there's two numbers here that make these fractions undefined. The fraction negative 5 over 4 and positive 4. So if you were actually going to try to solve this equation, if you wound up with either of these numbers as solutions, you would have to mark them out. When we start solving these equations, you're going to see that there's an option of no solution. Now, the no solution would happen if these were the numbers we got. Okay? So let me type in 4 and negative 5 over 4. 4, comma, negative 5 over 4. Okay. The next one is the same type of problem. It just looks a little bit more involved. Let me write it down and then switch over. This is problem 2. 105. 1 over x minus 4 plus 1 over x plus 2 equals 1 over x squared minus 2x minus 8. X minus 4. Okay, checking to make sure I didn't miscopy it. Well, the denominator of a fraction can't be 0. So this first one's pretty easy. In fact, I think we've already done it. Up here, this x minus 4 can't be 0. So x can't be 4. There's one answer. The next one's pretty easy too. The x plus 2, that denominator can't be 0. So x can't equal negative 2. Now the next one isn't quite as easy, is it? Well, what makes this one harder than these two? Well, the fact that there's that x squared. So if I do this, will that give you a hint on what you could do to make it easier? Factor this bottom.
And we already have the factors written there.
And they're right here, yeah. Every one of them, it's going to be rigged where you're not actually going to get any new numbers. It's going to factor as x minus 4 and x plus 2. So if you set the x minus 4 to 0, you get a 4, which we've already done. And the x plus 2 to 0, you get a negative 2, which we've already done there. Everyone's number 2. This third fraction will factor like that. Okay, so a positive 4 and a negative 2 are the answers I'm going to punch in. 4, comma, negative 2. I'll check it. So number 2 looks difficult, but really isn't that bad at all. Here's a similar one. What are the answers going to be? This is still number 2. I'll click similar exercise. Okay, so it'd be a positive 1 and a minus 2. Is that what I'm hearing? Okay. And if you factor this x squared plus x minus 2, it's going to be x minus 1, x plus 2. So rig like that on all of them. Okay. So how the heck do we actually go about solving these equations? We found out how to find the numbers that aren't possibly solutions. Okay? But how do we actually solve the ones? Well, let's look at number 3. I sort of hinted at how you're going to solve these the last time on that last problem with the quadratic formula, where you had some fractions in it and we multiplied through to get rid of the fractions. That's sort of what we're going to do here. Let me write it down. This is problem 3. 2x plus 5 over 2, then a minus 3x over x minus 3 equals x. 2x plus 5 over 2 minus 3x over x minus 3 equals x. Well, you can multiply both sides of an equation by anything you want. So what I want to do is cancel out those denominators. If I multiply it straight through, remember how you can do that cross-canceling? If I multiply it straight through by 2, that would cancel out that denominator. But it's not going to cancel out this other one. So multiply through by x minus 3. This is going to be pretty messy. Multiply straight through by those two denominators. 2 times x minus 3. When you do that, let me go ahead and cancel out the stuff that's going to cancel. Notice, even over here where there's no fractions, you've got to multiply by the 2 times x minus 3. So if you have two completely different denominators, just multiply straight through by those denominators. I'm now going to write out what's remaining. I'll stick with the color. Just right here on this fraction, we have the green x minus 3 times the blue 2x plus 5. Then this minus. I know it's because of the zooming, I think. I wonder what's happening. Let me see if I remove the zoom. It's still, pause it. See what happens. Well, I guess it ain't. Well, I'll just do it the. Try. Oh, it's still not focusing. Well, we come over here and try it like that. Try focus lock. Oh no, I don't want to do that. It's not focusing at all, is it? Oh gosh. Well, let me see if I unpause it. Oh, it's still recording. I thought I'd paused it. Oh, let's see. Okay, there. Okay, it's a pause. Okay. So let's see. So the x minus 3 and the 2x plus 5. Here, the x minus 3's cancel. So we have the green 2 times the blue 3x. I'm going to go ahead and write that as 6x. And on the right-hand side, we have 2x times x minus 3. I think I'll go ahead and distribute that 2x right now. And we'd have 2x squared minus 6x. Oh, there it is, starting already. Now, did everyone sign up beside their name on the attendance sheet? If your name's not on here, you need to tell me. It should be on one of these pages. Okay. Now, let's see. How are we going to go about solving this equation? Well, this one's kind of messy, let me tell you. We're going to have to FOIL out this x minus 3 times 2x plus 5. So we'd have 2x squared, then a plus 5x, a minus 6x, and a minus 15. Then we still have that blue minus 6x. Let me write that down. And over here on the right, we have the 2x squared minus 6x. Right here? Okay, I have the 2x times x. So I'm distributing. So 2x squared minus 6x. Okay. Any other questions there? And this one's going to start, stuff's going to start subtracting out pretty nicely. What do I mean by that? At first glance, it looks like this is a quadratic equation because there's that x squared. But I don't think it is. What do I mean by that? If I try to group these two x squares together, if I move this over, or whatever you want to call it, subtract 2x squared from both sides, do we have any x squares remaining? See, those x squares are subtracting out, aren't they? So this is not a quadratic equation. It's a linear equation. Now, let's see. You can solve this linear equation in as many or as few steps as you want to go through it. I think what I'm going to do is combine over here 5x minus 6x minus 6x. Or I guess you can move this 6x over. If I move this 6x over here, is that going to cancel out with one of those 6x's there? Oh, this one's sort of messy, and the fact that it's having so much trouble focusing isn't making it any better, is it? So what do we have? A 5x minus 6x, so that's a negative 7x. Negative 7. Where did I get that? Is that just a negative x? And we still have this minus 15. Now we have a 0 on the right-hand side. A lot of stuff subtracted out. Look through that messy manipulation. It won't all be quite this messy with the manipulation, but let's see what I did there.
The 6x on the right side cancels out.
Yes, with this one over here, or even with the other one, it doesn't matter. It's gonna, when you add 6x to both sides, it's gonna get rid of one of those minus 6x squares. Now we have a linear equation, so isolate the x. Well, I think what I'm going to do is, instead of moving the 15 over here, if I move the 15 to the right, I still have that negative in front of the x that I need to get rid of. I'm going to move the x to the right by adding x. So we just have x on the right equals negative 15. So negative 15 is our solution there. Pull it back. Negative 15. Now notice that other option of the empty set. What would make this fraction undefined here? What would give me a 0 in the bottom? A positive 3. If you had wound up with 3 as your answer, you would have to choose this empty set. I'm not sure if that ever happens on the homework. Okay? So negative 15 Any questions? This one was kind of messy. Let's do the next odd one, number 5. Here's problem number 5. Let me write it down. This type of equation appears or happens quite a bit. You'll see them where there's an x squared and an x. So if there's an x squared and an x, how do we get rid of those fractions? 5 over x squared minus 54 over x equals 11. Well, to cancel out those fractions where you have an x squared and an x, you don't need to multiply by both of them. Just use the one with the bigger denominator. If you multiply straight through by x squared, even the 11 you have to multiply by x squared. And I'll write that green x squared as x squared over 1 so you can see the way it cancels. This cancels out real nicely. It's not as messy as the one we just finished doing. So let's see. Here the x squares cross cancel. On the other one, the x cancels with one of these green x's here. So I'm just going to mark out the square. And let me write what's left after all that canceling. We have a 5. The minus I'm about to write is this minus. What do we have here? A 54 and a green x. Equals 11x squared. Well, this one's not going to simplify down to a linear equation. There's no way you're going to be able to get rid of that x squared. So I'm going to move everything over to the right because I like the x squared term to be positive. I think I mentioned that the last time. So I'm adding 54x and I'm subtracting 5. So I'm getting a 0 on the left. And on the right-hand side, I'm writing it in standard form. X squared, x, and then constant. The constant is the number that doesn't have a variable in it, or attached to it. And now, I'm going to factor this. As a rule of thumb, unless it says use the quadratic formula, it'll factor from here on. Okay? Whether it's in the homework or in the on a test. Well, okay, I don't even know if I need to write them out, but I will. Not a lot of numbers multiply together to give 11 or 5, right? So this thing's going to factor. Let's see, how am I going to make this thing work out? Second sign is minus. So 1 plus and 1 minus. I'll wait to fill that in. I'll try x times 11x. And the only way this is going to work is with that 1 and 5. How do I need to arrange it? What's going to go with the x and what goes over here with the 11? Put the 5 here? Right here? I'll put the 5 there by the 11 and the 1 there. Can I make this thing work out and give me a positive 54x? I sure think so. These little marks here are inner and outer when you're foiling. We have a 55x, a 1x, to get a positive 54x. The bigger number should have the plus. So we would need positive 55 and a minus 1 to get a positive 54. So right here in front of the 5, what should I put? Plus, and down here, over here, a minus. Would that do it? If it's been a while since you've factored, then yeah, you're just going to have to work harder at it. Okay? This factoring, Math 371, I used to teach that a lot. And it's been 6 weeks doing this factoring stuff. And I'm trying to jog your memory in just a day or so over all of that.
Larger number is sign of the middle number?
Yes, This larger product here should have the sign of the middle number. That's right. And after all of that, we're still not through. You got to set each factor to 0. Oh, I'm running out of room. Setting each factor to 0. We get x equals, is that a negative 5? What about this one over here once we isolate the x? What do? We move the 1 over and then divide by 11. Are y'all caught up with me? So what 2 numbers am I going to type in? Negative 5 and a positive 1 over 11. Is a very common type of equation where there's an x squared and an x. You'll see that pop up several times. Let's see, a negative 5, comma, 1 over 11. Any questions there? Now, problem 6 is a type of equation that's going to be popping up throughout the semester. This one is fraction equals fraction. That's the thing that makes this one. I'm going to show you how I do, or how I go about solving an equation that's in the form 1 fraction equals 1 fraction. Like the one we just finished doing. Number 5. That wasn't just 1 fraction equals 1 fraction. Hopefully you see how these differ. What do we do when there's just a single fraction on the left? Maybe it's a big fraction, but it's just 1 fraction on the left and 1 fraction on the right. Let me write it down. (2x minus 7) all over x equals x minus 2 over 5. Oh, let me lift it up. Okay. Well, one thing we could do to get rid of these fractions is just multiply both sides by an x. That would cancel out this one. And what else? What else would I need to multiply both sides by? A 5? So if you want to go 5x, and cross cancel over here, that's fine. What I do when it's just a fraction equals a fraction, I'll make these little marks like this. Which means cross multiply. And that's even at the end of the semester when there'll be something, a fraction equals a fraction, I'll ask, what am I going to do? And someone will say, cross multiply. So much of this is you're learning me. What am I doing? I'm telling you how This stuff has more than one way to do it, so I'm showing you the way I think is easiest. So I'm going to do this. X times x, that would give the x squared. Then minus x times that minus 2 would be a minus 2x equals 2x times 5, that's a 10x. And then, is that a minus 35? Well, may as well get used to the terminology. This is an equation. How do I know it's an equation? Because there's an equal sign. Is this a linear equation or a quadratic? It's a quadratic because of the x squared. So with a quadratic equation, get a 0 on one side and either factor or use the quadratic formula. These will factor. So I'm going to make my little marks. I'm moving everything over to the left. I like to keep that x squared positive. So that's going to be what? A minus 10x from both sides. And when I move that 35, is that adding 35? So here's the equation I'm going to try to factor. X squared minus 12x, and what did I say? Plus or minus 35? Plus. Okay. So this is one that I think is an easier problem to factor. How do I decide what's easier and what isn't? Well, if there's not a number in front of the x squared, those are called simple trinomials. Those are easier to factor. Why? You just put x and x in the first spots. And you can almost sort of figure out, okay, without writing out all the numbers that multiply together to give 35. Not that there's many. There's 1 times 35 and 5 times 7. And if you're out there listening, watching this later on, if it gets posted on YouTube and you think, that idiot, there's billions of numbers that multiply together to give 35. Yeah, I know 1/2 times 70 would give 35. I know there's a lot of decimal numbers that would multiply together to give 35. So when I say what numbers, I just mean whole numbers. Okay? So which one do y'all think it is? X and X. Oh, what do we know about the signs? The second sign is plus, so 2 of the first, minus and minus. 1 times 35 or 5 times 7? Yeah, 5 and 7. Those add together to give that 12. That's it. So set each one of these factors to 0. And we get x equals 5 for our first number. And x equals 7. Okay. 5 and 7. I don't know if y'all noticed this or if you saw it, but if you clicked on document sharing on My Math Lab, there's a document there which is just every problem I worked out. There is a PDF, and so I'll do that same thing for these. The ones I'm working out, these sheets of paper, will go under document sharing with some name about, class notes from today, whatever today's date is. So a 5 and a 7. Come over here. 5 and 7. Is that it? But I do the cross multiplying when it's fraction equals fraction. Okay. Is this one here, this next one, a fraction equals fraction? No. If we didn't have that 7 plus, then it'd be fraction equals fraction. I think it actually turned out to be a much harder problem. But let me write this one down. This number 7. 2x over x minus 2 equals 7 plus 6x squared over x minus 2. Okay. By the way, sometimes students say, oh wow, do I have to show like this stuff here? I can get these answers faster than you are. Your goal and mine are different. Your goal is to get the answer as fast as possible. My goal is to show thought process. Okay? So do you have to show every step I'm showing? No. Get that answer as fast as possible. But this is not a fraction equal fraction problem. So I'm not going to cross multiply. There's two fractions, and fortunately they both have the same denominator. So to get those x minus 2's to cancel out, would y'all just multiply straight through by x minus 2? Now be careful. Every term, even this 7, has to be multiplied by x minus 2. Oddly enough, that big concrete pillar doesn't bother me anymore. Okay, so things could always be worse. The wall could be closed. See, like right here, once I cancel the x minus 2, all I have is the 2x. Over here, I can distribute that 7x, so that would be a 7x minus 14. And then plus, what am I about to write? 6x squared. These x minus 2's cross cancel, leaving just that 6x squared. And let's see, linear or quadratic equation? What do we have? And how do we know which one we have? It's a quadratic equation because of the x squared. So get a 0 and factor, or use the quadratic formula if you want. I'm going to, whenever I can, I factor. Since I like the x squared to be positive, I'm moving everything over to the right. I don't want to move the 6x squared over to the left because that would make it negative. So if I just do this, subtract 2x from both sides, that's putting a 0 on the left. And then, what do we have? A 6x squared, a plus 5x, and a minus 14. Where did that 5x come from? Oh, right here when I subtracted the 2x from both sides to get the 0 over there. The 7x minus 2x is 5x. And notice how I'm writing it in that standard form. X squared, x constant. Yeah, I always want that in that form. And it doesn't matter if I'm solving it or using the, factoring it or using the quadratic formula. It's easiest if you have it in that standard form with the x squared number positive. Okay. Well, let's see. Numbers that multiply together to give 6. Numbers that multiply together to give 14. This one, it's a little harder to factor, I think, than the one we just did. And there's no number in front of the x squared. Those are the easier ones. When there's a number in front of the x squared, you got to sort of do some trial and error with it. I think I'm going to try the 2x and 3x with the 2 and 7. But, no guarantees that's how it's going to work. And I don't think it is. No, it's not going to work with a 2, 3, and a 2, 7. So this is what I'm trying first. 2, 3 paired with a 2, 7. It's really not that many possibilities because if you remember, there can't be common factors other than 1 in the parentheses. You can't have 2 of the same number. You can't have 2 even numbers in the same set of parentheses. So if I'm going to test it with 2 and 7, I can't have the 2 here. It would have to have a 7 there, a 2 there. Can I make it give me that 5x? Oh, keep it in mind, the second sign is minus, so there's a plus and a minus. When you look at this, 21x and 4x, am I going to get a 5x out of that? No. So the 2, 7 won't work with the 2 and 3. So if I'm going to go about it, I could try, just a matter of which one you try first and get it to work. I'll try the 2, 3 paired with the 1 and 14. If that's going to work, I'd have to put the 14 there. Oh no, the 1 there and the 14 here. Why am I saying that? Well, I can't have 2 even numbers. But after all of that, I don't think this one's going to work either. I would have 3x and a 28x. Oh, I'm not, let me, out of range. So, at this point, I can conclude that the 2 and 3 is not working. Well, if it's going to factor, it's going to have to be with the 1x and the 6x. And y'all want to try it with the 2, 7 or the 1 and 14? At 2 and 7, the 2 can't go with the 6. You can't have 2 even numbers. So if it's going to work, it's going to have to be like that. 2 and 7. I think this one does it. This works. We'd have a 12x and a 7x. If I want a, what was that middle term, a positive 5x, the 12 would need to have that plus, so the 7 would be minus. Which would be put the plus here, the minus there. So I finally got it factored. Any questions there on that factoring? To keep in mind, you can't have common factors other than 1. You can't have 2 even numbers. You can't have 2 of the same number in the parentheses. That helps you eliminate some of the possibilities. So, setting each one of these to 0. When I go x plus 2 equals 0, and isolate the x, I get a negative 2. When I set 6x minus 7 to 0, what am I getting? Move the 7 and divide by 6. So 7 over 6 is one answer. Negative 2 is the other. So negative 2 and 7 over 6. Negative 2, comma, 7/6. Any questions there? I think maybe that was the most involved one. Any questions? To solve an equation that has fractions, the idea is you've got to get rid of the fraction. Multiply by whatever it takes. Like on this one, multiply both sides by x minus 2. Make sure you're multiplying every term. Terms are separated with addition, subtraction, and equals. So there's 1, 2, there were 3 terms. That's why we multiplied 3 by x minus 2 on 3 things, including that 7. The common mistake is to not multiply that 7 by the x minus 2. Okay? Now, on day 1, we had a rule that said something like this: the square root of a, I think first we wrote it square root times square root, the square root, and then when we were defining complex numbers, I wrote it like this: square root of a squared. A square root and a square cancel each other out. Well, just like square roots, we can have cube roots, fourth roots, fifth roots. So I'm going to extend this rule, and I'm going to do it the lazy person way. A cube root and a cube will cancel each other out. A fourth root and an exponent of 4 cancel each other out, and so forth. Whatever the root is, and most of the time it's just square roots. But if you had some root other than a square root, like a cube root, a fourth root, fifth root, then that power would cancel it out. The way you write this in general without having to write it out so many times, you can write this. This is a lowercase n I'm writing. The nth root of a raised to the n power. Whatever this root is, if that exponent is the same thing there, those cancel each other out.
And by extension, say, would it be correct, a square root cube is simply a squared?
But a square root cubed would be...
A squared?
No, if you cube the square root, you're going to wind up with... If you cube the square root, you would have to think of it like this. Square root of a times square root of a times square root of a. This, the square root times itself, that's a square. That would give you an a, but you'd still wind up with a square root remaining. Okay? Unless I'm misunderstanding the question. Is that what you were asking? Oh, okay. If it were a fourth power, then you'd have a times a squared. That's ahead of the game. Okay? Now, what we're going to do next is solve equations that have square roots in them. And I think it'll make more sense if I'm going to write out the steps. And the steps might make more sense if you see the example I'm going to do, but I'm not going to write down this problem yet. Okay? This is the problem I'm going to do in a moment. Well, you know what? I'll go ahead and write it down right here on this sheet of paper while it's showing. This is problem number 9. Once we're through with number 9, we'll take our break. The square root of 5x plus 60, then a minus 7 equals 2x minus 13. Write out how we're going to solve these equations that have radicals. That's what you call the square root, cube root, fourth root, those symbols. This little funny looking symbol that looks sort of like a division symbol. You can refer to those collectively just as radicals without having to say square root, cube root, fourth root, so forth. Okay? So I'm going to write out a strategy for solving radical equations. How to solve radical equations. The first thing you're going to have to do is isolate the radical term. If there's two square roots or cube roots, put one on each side. Okay? If there's only one of them, you've got to isolate. Isolate the radical term. So this example I'm about to do in a moment, once I write out these steps, I sort of want to write out all the steps and then we'll do this example, just to try to explain what I'm saying on each step. Like right here, what do I need to do to get this square root by itself? Move that 7. Okay? So that'll be the first step I do in a moment. Then, after I've moved that 7, cancel out the radical by raising both sides of the equation, by raising both sides of the equation to a power equal to the root. What the heck am I saying there? Well, if it's a square root, you're going to square both sides. If it's a cube root in the problem, cube both sides. Use whatever exponent the root is so that it can cancel out. And then, once you've canceled out that radical, solve the resulting equation. Usually you wind up with a quadratic equation, not a linear, but sometimes you might wind up with a linear. And then step 4, for even roots, you must check your answers. If you're solving an equation that has an even root, what do I mean by even? Well, what are the even numbers? 2, 4, 6, 8, 10. So if you have a square root, a fourth root, a sixth root, you have to check your answers. It's possible that you're going to get numbers that aren't actually solutions. Now, if it's an odd root, like a cube root, the odd numbers 1, 3, 5, 7, 9. If it's an odd root, you don't need to check your answers. Okay? So, now follow through those steps as I do problem number 9. The homework. So, following these steps right here. First of all, isolate the radical term. Okay? What did we say we need to do to isolate that radical term? Move that 7. That square root needs to be by itself. So we just have a 5x, square root of 5x plus 60 on the left. Then when I move that 7, I'm going to have a 2x. And then what am I going to have when I move that 7? Okay, so a negative 13 plus 7. Is that going to be a negative 60? Y'all see what I'm doing? Getting that? I'm adding 7 to both sides. So that negative 13 plus 7, that's where I'm getting that negative 6. First of all, isolate the radical term. Now comes the critical part where I have to cancel out the radical. Well, what'll cancel out a square root? A square. So you're going to square both sides. And the left-hand side simplifies really easily. The square root and the square cancel, leaving just the 5x plus 60. Okay. The square root and the square cancel, leaving just 5x plus 60 on the left. But on the right, you've got to be careful. You don't just square the 2x and square the 6. It's a 4-letter word in algebra that starts with F. What am I going to have to do to square? FOIL it out. Okay? So I'm going to go ahead and write it out again right here. Or maybe you can FOIL it out just in your head. I'm writing it out twice. And now FOILing it out. We'd have a 4x squared minus 12x minus another 12x, and plus 36. What I'm hearing. A word of warning. This problem's about as involved as it's going to get, okay, in this assignment. So don't let it intimidate you too much. Well, what kind of equation do we have? Because now we've got to solve this equation. Well, there's an x squared in it, so I'm thinking it's a linear, not a linear equation, is it? It is a quadratic equation. So get a 0 on one side and factor, use the quadratic formula. I'll factor. Now let's see. Here's what I'm going to do. I'm going to move the 5x over and move the 60. So I'm getting a 0 on the left. Why? I like that x squared term to stay positive. Oh, so we have a 4x squared. Okay, so I have a negative 12x, a negative 12x. Can y'all follow this? And I'm moving this 5x, so we have a negative 5x. So negative 12 plus negative 12 plus a negative 5. Is that going to be a negative 29x? 20 short years, we'll be finished. And that's my pep talk. I'm convinced in a previous life I was a motivational speaker, and that's a joke. 36 minus 60, would that be a minus 24? Now see how I moved everything over to the right? Go through it and make sure you follow that. How I'm getting this minus 29. I have a minus 12, or a negative 12, a negative 12, and a negative 5. That was this one here. Negative 12 plus negative 12 is negative 24 plus a negative 5, negative 29. Moving the 60 over, 36 minus 60, negative 24. I'm going to factor this. This one's actually a really good factoring exercise. Numbers that multiply together to give 4. Numbers that multiply together to give 24. Remember years ago I had a student when I was teaching Math 371 a lot. And on day 1 she told me, okay, it took me 7 semesters to pass Math 370. That was the arithmetic course that the school used to offer. And I'm sure I'm going to take at least 7 semesters to pass this course. I'm going to take you every semester until I pass. Fast forward 3 semesters. We were up to factoring in that same class. She's still in there, taking me every semester until she passed. And we were doing a problem just like this. And the number was 24. And she said, stop right there. That's what's giving me trouble. Where are you getting these numbers? She pulled up her calculator and showed me. She punches 24 into her calculator, but it doesn't give her these numbers. How are you getting those numbers? And the rest of the class, I felt sorry for her. The rest of the class sort of laughed. And I was like, that's the multiplication tables. It might be in a very non-threatening way, suggested maybe she should practice those multiplication tables. I happened to, I had some multiplication tables in my office I got and gave to her. Told her, you just sort of got to know those multiplication tables to do this. Then what did I do afterwards? I went down to my boss's office and told him, I'm ready to take a break from Math 371. That's been 10 years, so a break from me always becomes a very long break. So this is a really good factoring problem. Why? It illustrates something that I've said. You can't have common factors other than one. In particular, you can't have two even numbers. If I try this, I can discard it pretty quickly. You can't have 2x times 2x. That's not going to work. Why? Well, I couldn't put the 4 or 6 anywhere here, could I? What about the 3 and 8? Well, I couldn't put the 8 anywhere. The 2 and 12 couldn't go anywhere. The 24 I couldn't put there. There's no way this 2 and 2 is going to work. Because if I do, I'll wind up with two even numbers in the same set of parentheses. That's why I said this is such a good factoring problem. The 2 and 2 can't work. So I'm going to try the x and 4x. Or 4x times x, however you want to write it. But be careful. You can't have two even numbers. So if this thing's going to factor, would the 4 and 6 work? It can't, because you can't have a 4 or a 6 right here, or you have two even numbers. If the 3 and 8 are going to work, how would I need to arrange it? I would have to put the 8 here and the 3 there. Is this going to work? If I draw my little marks and look at the inner, I have 32x. The outer, 3x. I forgot, what was the middle term I wanted? Negative 29x. If I subtract 32 and 3, I can get a 29. So the bigger product should have the minus. Should be like this, a minus in front of the 8 and a plus in front of the 3. It's a good factoring problem. A lot of possibilities, but you can knock out a whole lot of them. Oh, yeah. Okay. So, oh wow, 20 short years, we'll be finished with this one. I wanted to do it in case some of y'all leave after the break. Or at the time of the break, at least you will have seen the most involved one. So set each one of these factors to 0. And isolate the x. So the first one we have is x equals 8. And the other one, I would move the 3 over. And then divide by 4. So a positive 8 and a negative 3 over 4. Now, there's a step I haven't done yet. For even roots, you must check your answers. That means plug into the original problem. Okay? And you should get the same thing on both sides. If I'm going to check these, which of these are the easiest ones to check? Which number would be the easier one to check?
8.
Yeah, the 8. Here's what I'm going to do. Okay. I'm going to go ahead and pull up this problem. And let's just see, maybe both of these numbers work. Maybe they're both answers. 8, comma, -3/4. When I check it, if it says correct, great. No. Okay? So it talks me through. Add 7, square both sides, solve, check your solutions. Okay. Well, that means either the answer is no solution or one of these numbers isn't a solution. Well, let's figure out which one it is. As a general rule of thumb, before it makes you choose a similar problem, you can try guessing or getting the right answer 3 times. Let's check the 8. Why am I checking the 8? Well, that seems like the easiest one. Okay, I'm plugging the 8 in for the x. So where this x is, I'm going to put an 8. And right here, I'm going to put an 8. And I'll show it as I write it out. I'm checking x equal 8. I'm plugging the 8 into the original problem. So that 5 times 8, that would be the 40, plus 60, then there's the minus 7, equals 2 times 8, 16, minus 13. I plug the 8 in to the original problem. Don't use one of the don't use one of the problems later on, or the equations after you've started squaring it and stuff. You must check with the original problem. I'm putting an 8 here. 5 times 8, that gets a 40, and then we have a plus 60, then the minus 7, and over here 2 times 8, that's the 16. That's what I was writing here. Let's continue simplifying. Well, 16 minus 3, that's pretty easy. 16 minus 13, that's pretty easy. 3. Are we getting a 3 over here? What are we getting over here on the left? 40 plus 60 is 100. What's the square root of 100? 10. Then minus 7. Are we getting 3 on both sides? That means 8 checks. Do I need to check the negative 3 over 4? No, we already know. Okay? 8. We already know that both of them aren't answers. One of these can't check. So I'll just eliminate the negative. Or I'm going to, let's see. Oop. There. Just 8 is the answer. It can't be negative 3 over 4, because if negative 3 over 4 had been an answer, if it checks, then I would have gotten it right when I put both of them in. So I'll say check. And we'll take our break now. So it's late. So we'll go 9:30 to 9:40, okay? So there you go. We'll do more of these.